Hello students, let's see another question which came in GATE 2019 Civil Engineering. This was question number 48 in the afternoon session. So the question states that at the foot of a spillway, water flows at a depth of 23 centimeter with the velocity of 8.1 meter per second as shown in the figure. This is the figure. This is the spillway shown to us and water is flowing over it, and the depth of water at the toe of a spillway is given as 23 centimeter and the velocity is given as 8.1 meter per second. It is also stated that the flow enters as an M3 profile in the long wide rectangular channel. Point to be noted, this is long wide rectangular channel with bed slope is given as 1 by 1800 and the Manning's coefficient n as 0.015. A hydraulic jump is formed at a certain distance from the foot of the spillway. Assume the acceleration due to gravity g as 9.81 meter per second square. Just before the hydraulic jump, the depth of flow y1 in meter round off to 2 decimal places is asked. The reference to solve this question could be found out in lecture number 9 on hydraulic jump and celerity in the course of river engineering by Dr. Subhashish Datta, Department of Civil Engineering, IIT Guwahati. First, let us see what all data is given to us. It is stated that velocity as 8.1 meter per second at the toe of a spillway, where depth is 0.23 meters and the slope of bed channel S0 is given as 1 by 1800. Manning's coefficient is also given as 0.015. Acceleration due to gravity is given as 9.81 meter per second square. It is also stated that this is a long, wide, rectangular channel, which means that its width is much greater than its depth. So first let us find the discharge at this point. So discharge will be given as area into velocity. Area would be given as b times y into velocity, and as we don't have the value of width of the channel in this question, so let us convert this into unit discharge, that is Q by V, that is discharge per unit width. Q would be equals to Y times V. Y is 0.23 meter and V is 8.1 meter per second. If you solve this in calculator, it will come out to be 1.863 meter cube per second per meter. Now let us calculate the normal depth for this flow. Normal depth Q would be given as B times Y0, which is the normal depth, divided by Manning's coefficient n, r to the power 2 by 3 under root S0. And as in the question it is stated that it is a long wide rectangular channel, so r, as it is stated as A by P, would be equals to By by B plus 2y, which would be approximately equal to y. So in terms of unit discharge, it will be equals to Q equals to Y0 by N, y to the power 2 by 3, this would be Y0 under root S0. Therefore unit discharge Q would be equal to Y0 to the power 5 by 3 divided by N into under root S0. We have this unit discharge with us, we have Manning's coefficient, we have bed slope, so Y0 can be calculated from this equation, which would be 1.863 equals to Y0 to the power 5 by 3 whole divided by 0.015 into under root 1 by 1800. After solving, it will come out to be Y0 equals to 1.107 meter. So now we have normal depth of flow, that is this Y0 as 1.107. Corresponding to that y1 we have to find out. This can be done by using Ballinger momentum's equation, but for that we need to find out the Froude number. So Froude number can be found out F R0 equals to V divided by root GY naught. For that we need to calculate V first at this point. So V will be equal to 1 by 0.015 into 1.107 whole to the power 2 by 3 into 1 by 1800 If you solve this, it will come out to be 1.682 meter per second. Put this value in this equation, you will get it as FR0 equals to 1.682 divided by root G is 9.81, Y0 is 1.107, which give us FR0 as 0.510. Now you can easily use Ballinger's momentum equation to find the value of Y1. So it is Y1 by Y0 equal to -1 plus whole under root 1 plus 8 FR0 square whole divided by 2. So we have these values -1 plus under root 1 plus 8 times 0.510 whole square divided by 2, which gave us the value of Y1 by Y0 as 0.378. So Y1 would be equal to 0.378 times 1.107, which comes out to be 0.418 meter. Round off to 2 decimal place, it will be 0.42 meter. So 0.42 meter would be the correct answer for this question. Thank you.